Let's think about these equations, pair of equations. Let's have a look at the A, equations in A. Can we say something, just by having a look at the equation? Can we say something about the line? That's my question. Because you should get used to, whenever you look at an equation, you should somehow be able to see if there is a relation, if there is something that the equation is trying to say. Do you think this equation looks like this?
First equation चाहिँ उबाट हुन्छ दुवैको चाहिँ उबाट हुन्छ के सेन्टरबाट जान्छ 0.0 ओरिजिनबाट जान्छ.
In the first equation, why? Because there is no intercept. When is intercept not 0? Or when is intercept 0? When does a line not make intercept? When line passes through origin. That means one thing is certain, that the equation is either lines are somehow like this, one of these. Yes. You should immediately recognize that. Because there is no intercept, okay, the line is like this. Do you think it is going down, steeping down, or it's going up? Look at the first equation.
Down.
What do you think?
First go down. The second
First.
go up.
First one?
Down.
Why? Because slope is, how much is the slope?
Slope is minus 3 divided by 4.
Minus 3 divided by 4. So slope is down. That means as you run, the rise is decreasing. The run, if you move along x, y is decreasing. Right? That's what it means to have negative slope. Right? So therefore, there is something else that you can say. It cannot be this one. Because here what is happening, if you move along x, what is happening? Y is rising, right? This one is greater than this one. As you move along x, right? It should be there, therefore, what? It should be somehow like this. Because if you move along x, that means here, y is this much, right? When you move along x, y is this way. If you move here, y is this much. Y is decreasing, right? Y is minus here. Here, minus 1, let's say. Here, probably minus 4. It's decreasing. So therefore, you see, you can find so many things just by having a look. That's what I want you to say. And in the other case, it's different. Right? It's going through origin, but the slope is positive. That means the line is moving upward, it's rising upwards, right? The slopes, it's steep upwards. And then, next,
B is parallel.
these two lines are
Parallel. Because they are slopes.
Right. So if you want to check whether given two lines are parallel or not, all that you can do is you can observe this part, this one and this one. Whatever is at the back does not matter with the slope. Right? Whatever is this part, this C part, this constant part does not tell us about slope. It tells us about intercept. But this part tells us about slope. If they are same, that means y equals to something same, right?
Yes.
So therefore, same. So they will move through origin. They have same what? Slope. That means they are parallel. What about C?
They are perpendicular.
They are perpendicular. Why are they perpendicular?
The product of their slopes is minus 1.
Minus 1. Right? So minus 1. Why is it minus 1? What is slope?
Slope minus 3 by 2.
So this one is
Minus 3
by 2. This one
is 2 by 3.
2 by 3. 3 by 2 minus 2 by 3. Minus 2 by 3 gives you
Minus 1.
minus 1. Right? This one is minus 3 by 2. And this
2
one
by
is
3. 2 by 3.
So look at the numbers, how they are playing. If you consider this 3 is with x, but here 3 is with
Y.
right? The coefficient of y is 3, the coefficient of x is 3 in this one. The coefficient of y is 2, the coefficient of x is. There is something interesting, right? There is something interesting. That means there is an exchange of coefficients. Coefficients are exchanging, right? Coefficients are exchanging. X has 3, y has 3. Y has 2, x has 2. There is an exchange of coefficient, and one of them is negative. One of them is
Negative.
just by exchanging coefficient, it does not become perpendicular. There has to be one sign negative, or the sign has to change. That's interesting. Perpendicular. Okay. What about this one? Very easy.
It passes through origin.
Y passes through origin, all of them, right? That is sure. Because there is no intercept. Another thing. Y equals to 0. Where does this line? Where is this line? Y equals to 0. Origin to origin, Baba. Origin, there is origin. Millions of Y equals to 0. Where is this line?
Y-axis.
No. Y-axis. Is this Y equals to 0? No. Which? X-axis. X-axis, because this is Y equals to 0. Along X-axis there is no Y. Along X-axis there is no Y. But if you take Y, if this was Y equals to 0, here if you see, this is not Y equals to 0 here. There is this a point where Y is 0?
No.
Is this a point where Y is 0?
No.
Is this a point where Y is 0?
No.
This is the only point where Y. But here if you take this point, this point, this point, this point, any point on x-axis, that is Y is 0. What about x equals to 0?
Y-axis.
Y-axis, right? Here, no matter which point you take, x is always 0. Do you understand this?
Yes.
Clearly?
Yes.
Clear?
Yes.
Don't get confused with x equals to 0. It has to be x-axis. No, it is y-axis actually. Along y-axis, x is 0. Along x-axis, y is 0. Similarly, let's have a look at x equals to 3. Where is this? So you have to find a line where x is always 3.
Parallel to y-axis.
Parallel to y-axis. I have to find a line where all the points on that line will have x coordinate 3. Where is it?
And positive.
1, let's say 2, 1, 2, 3. So if I draw a line like this, take any point here, here, x is 0. Or the x is 3. Is it true? X is 3?
Yes.
No!
No, actually not.
Here x is something else. Here x is something. Here x is something else.
Y
equals to 3.
Y equals here. Here. This is the line where x equals to 3. Here also, from y you are in this distance. Here also, no matter where, all of these points, they have x coordinate as
3.
What about y equals to 5?
Y is
Y
parallel
is
to
x-axis.
1, 2, 3, 4, 5. If you take this line, then this is y equals to 5. Right? Because if you take any point here, x coordinate is changing. But y is alright. So these are observations you have to make. When you look at a line, you should be able to find something about that line, that equation, okay? So far